welcome back. In this video, we are going to start with a topic that is concentration of defects in a solid. So, firstly, we will learn about Schottky defect and then we will move to Frankel defect. So, Schottky defect, the terms that are used in Schottky defect are N as atoms, small n as variables, V as internal energy, and EV. EV is known as energy required to displace the atom. So now the number of ways in which an atom or a molecule that can be displaced can be estimated by applying theory of probability, which is given as W is equal to capital N factorial by capital N minus small n factorial into small n. This is first by Boltzmann equation, which is given as capital S is equal to capital KB log W, where we previously have seen about the first equation, that is W is equal to log capital N factorial by capital N minus small n factorial into small n factorial. So again we substitute that first equation into the second equation. So we get this equation. Now in this equation, what is KB? KB is Boltzmann constant, and S is entropy, and W is number of ways in which the atom is displaced. Now we need to further derive this equation. So firstly we will do some of the derivation. We start with the log A by V. So log A by V can be written in the form of log A minus log B. Capital N factorial minus small n factorial into n factorial. So we use that log and we make KB is equal to log A. Log A is n factorial, then minus log bracket. Here we will write n minus capital N minus small n factorial. Guys, here capital N and small n, both of them are different. So write it properly so that you don't get confused. And here I'll write here n factorial. Now KB log n factorial minus log A. Log AB can be written in the form of log A plus log B. So now we will write this in the form of log A plus log B. And further it get the sign of minus gets inside, and that plus log small n becomes minus. Now we use here Stirling's approximation. Applying Stirling's approximation, we can write log capital N factorial can be written in the form of n log n minus n. So this can be log n can be written in the form of capital N log n minus n. Previously we have seen the derivation, half derivation, and now this is the complete derivation. KB is equal to using the Stirling's approximation. We have we need to solve it further. So I have taken this previous equation and using Stirling's approximation, by using that formula, log n can be written in the form of n log n minus n. Similarly, I have applied on this and this log. Now we move further and we cancel the terms that are capital N and small n. and again we need to further apply Stelling's approximation on them, and we need to simplify it further, and at the last we came to this point that kb bracket log capital N minus n by n. So by using f is equal to u minus ts, where s is given here as this, so we need to apply s in this equation, and now log small n capital N minus small n by n, where n is again this n is guys constant. So again if we apply derivative partial derivative, df by dn is equal to 0 on the derivative part, and this can be written as the form of ev minus kbt into log capital N minus n by n, and this if we take EV on that side and minus minus gets subtracted, so EV is equal to, I'll write direct KBT by log n minus capital N, log capital N minus small n by n. Now here we need to take KBT on this side, so it becomes EV by KBT is equal to log capital N minus small n by n, and if you need to remove it is on this side only. If we remove log from this side, we get e to the power exponent. So e to the power, in the power we write this whole term is equal to capital N by small n into n. And now this term n capital N minus small n can be written in the form of capital N only. So this whole term becomes capital N by n, and write here n as it is, and we need to find the value of n. So to make it reciprocal, we need to make here the sign as in the power we need to write it here as minus, as if we write the term as is equal to 2 to the power 1, we write here as b by a is equal to 2 to the power minus 1, as we take power as minus 1. So by using this method, we write n become numerator, and capital N becomes denominator, and here we write it here as EV by KBT, and now small n becomes capital N into EV by KBT. So this is how we have proved the Schottky defect, and in the next video we will find the version of Frankel defect. And if you like the video, do like and share and subscribe, and if you have any doubt, do comment below, and till then, thanks for watching. Bye bye, see you in the next video.